Hey there! So you know already how to merge your changes back to the main or master branch. Great! And usually everything works just fine. But what if you are not the only team member working on some changes? What if your colleagues made some changes independently in the same piece of code that you did? What happens if both of you are trying to merge your changes? And that's when merge conflict might happen. And today I want to show you how to handle it, how to resolve it. So let's get started. Alright, so merging or handling merge conflicts. So actually, let me start with drawing a scenario when it might happen. So let me switch to whiteboard and let me start drawing it. So let's say this is our main branch, our source of truth. And let's say that we've got some code there already. And what the first developer does is to, create its own feature branch, just like we did in the previous episode. Feature branch for its own set of changes. And this person is making some commits, everything is fine, he's working on it, but it takes some time to develop all those new features. And at the same time, there is another developer who also created its own feature branch. Let me call it feature branch 2, and again from main. And he made his set of changes, but he made it faster, and he was able to merge them back to main before the first user did. So at this moment, our main branch contains changes made by the second user. And the first user working on this green branch is not aware of these changes. So what might happen is that when user 1 tries to merge his changes back to the main, it might happen that, hey, there is some conflict detected here because both users, user 1 and user 2, were updating the same part of the code. And in many cases, Git is smart enough to handle those independent changes on its own, without bothering you. But sometimes it might say, sorry, I don't know, you have to help me how to handle this case. And today, I will show you several use cases to show you what scenarios Git can handle on its own and when it requires your help as a developer. And in general, merge conflicts are normal. They are expected, especially if you're working in a bigger team. So sooner or later, you will face them, and you have to know how to work with them. Alright, so that's the scenario for today. And now, to keep it simpler, I will not be doing synchronization between local repository and remote repository. No, we'll get back to this later on. Today, let's just focus on handling conflicts. Alright, so let's start with the first use case. And basically, we'll be working on this scenario, but in various use cases, those two users will be modifying different parts of code. And we will see how Git reacts. So in the first use case, actually, let me write it down so you could have it on paper. So use case, use case 1 will be about making changes in completely separate files. So user 1 and user 2 will be working on different files, and we'll see if this can trigger a conflict or not. Alright, and we'll be working on our Azure DevOps remote repository. And I have two users, user 1 and user 2. Each of them has its own virtual machine opened that simulates their environments. So right now, this is our repo. We've got only the master branch inside our solution A repository. And let me switch to virtual machine of the first user. So let's go to this. So that's the VM of user 1. So on this VM, I have this repository opened in a web browser because we'll be doing stuff only here. Let's forget about the local environment for now, just to keep it simpler. So what usually would happen following our branching strategy is that whenever user wants to work on his set of features, he would create its own feature branch. So let's do this. So let's go to branches and let's create a new feature branch, and let me call it feature use case 1 user 1. And is this incorrect? Yes. And I want to base it on the master branch. That's our goal. And let's create it. And we've got a brand new branch. It doesn't contain any changes yet, but let's leave it for now. Actually, let's jump into this branch, and we'll be making some changes here in the front-end code. In the meantime, let's jump to the second user, to his own virtual machine. So let me switch the context. So that's the second user, this user 2, and he also has this repository opened. And actually, let's create a branch for him as well. So let's call it feature user 2 use case 1 branch or whatever. And again, it will be based on the master branch. So let's go with this. And now both users have their branches created. And let's continue working as the second user. So let's add a brand new file to his branch. So let's go to the front-end part and let's add a new file. And let me call it user2 file txt. And let's make some changes in this file. This is a file created by user2. And let me commit this. All right, so the change, this new file, exists in my user2 branch. That's fine. But right now, I want to merge it back to the master branch. And to do this, we know that we have to use pull requests. So let's create one. And I want to create a pull request from our user2 branch to master branch. So basically, we want to bring this new file that we just created into the master branch. And let's create it. And we can see that, yes, this new file we want to add. Now, following our configuration of Azure DevOps, this change, this pull request has to be approved by me, by Piotr. So let me jump to my Azure DevOps. So this is Azure DevOps where I'm logged in. And let's take a look at pull requests. So we can see that's the new pull request that has been just created. I would review it. I would say everything is fine. There are no merge conflicts as for now. So let me approve it and complete this. Yes, I say everything looks fine. So this change can be merged into the main or master branch, which is happening right now. So if we go to the master branch, we will see that this new file exists there, which is fine. So the second user completed his work. His scenario is done. So let's go back to the first user. Or actually, let me indicate where we are. So the second user completed his changes. He merged his changes to repo. The first user is here. He only created a new branch, nothing else. So let's add a new file in his branch, and then we'll try to merge it. All right. So this is user 1 environment. He doesn't see a new file that was added by the second user because he's working on his own branch. but that's fine. And let's add a new file. And let me call it user1 file.txt. And this file was created by the first user. And let me commit this. Yes, to branch, to our feature branch. And then again, we want to merge those changes to the master branch. So let's use a pull request. And yes, we want to merge this stuff that we just did. And again, this pull request has to be approved by me. So let me switch to my environment, to pull requests. And yes, I can see this new pull request created by the first user. And let me approve this. And let me complete this. And by the way, did you notice that there are no merge conflicts detected by Git, even though those two users made some changes independently? Both of them added their own files without knowing about the second user doing the same. And in this case, Git is completely fine to handle this on its own. It didn't detect conflict because, hey, I know that both of you made changes, but because you worked on a completely different parts of the code, different files, it is fine for me, for Git, to handle this. So no merge conflict, situation is super clear. And if we go into the main branch, or master, how is it called here, we should see both files available there. The one created by the first user and the one created by the second user. So it clearly means that if you're working on a completely different files, then there will be no merge conflicts because Git can handle it on its own, which is super cool. So that was the simple scenario. Let's jump to the second use case, a little bit more complex. So in use case 2, we will be again working as two users, but this time we will be updating the same file. So the same file, but it will be a different parts of the same file, and we'll see if Git will be able to handle it on its own. So again, let me jump to user1 environment. So that's the one. And let's create a new branch for him. So let's call it feature use case 2. That's the second use case. And branch created by the first user, like so. So the branch has been created. Let's go to this branch and let's do something similar for the second user. And again, in this case, second user will complete his work faster. So let me switch to the second VM and let's create, oh, command and cursor again disappeared. So it's a 9. Let me try to, oh, it's back. So let's create a branch for second user. So feature user 2 use case 2 branch based on the master branch, and that's fine. And let's go to this newly created branch. And now in this scenario we want to edit the same file by both users. So let's find some file, let's say this code.txt, and let's edit this. So let's say that the second user, the one that we are working on right now, modifies the first line. So this, oh, come on, this is the line modified by the second user. And let's say that's the changes we did. Let me commit them. That's fine. And let's merge them to the master branch. So again, we'll use a pull request. from our use case branch to the master. That direction is fine. Let me create it, and again I will approve it as me, as Piotr. So let's jump back to my environment, to pull requests, and that's the one that we want to approve. So usually I would verify what changes have been done, and I can see that yes, this part has been added in this code.txt file, which is fine. So I will approve and complete the merge, which means that the changes made by the second user are already available in the master branch. So now let's do something similar for the first user. So again, let's jump to the first user environment. We are on his branch, user 1, use case 2, and let's modify the same file that the other user did. And again, in this case, this user 1, he doesn't see those changes because they are not synced to his branch, but that's fine. And let's make a change in the same file, but in a different line. So change made by user 1. So this time I modified the third line, while the other user modified the first line within the same file, but different lines. So let me comment this. And let's try to merge those changes back to the master branch by using a pull request and see what happens. So yes, please create a new pull request. And take a look. Git says no merge conflicts. So even though those two users made changes in the same file, Git is smart enough to determine that, hey, you worked on a different parts of the file, so I will be able to merge those changes on my own. So let me approve this pull request as Piotr. So that's the pull request. Let me approve it and complete this. And let's see how the file will look like after merging those two set of changes. So if I go to the master branch, to our file, so that's the file, and take a look. It contains changes made by the second user and change made by the first user. So both changes were merged without any issues. So far, so good. Now, let's jump into the more advanced scenario. So in use case 3, we will again modify the same file by those two users, but this time we'll be changing the same line, the same part of the code, and we'll see what will happen this time. So again, let's jump to user 1 environment. Let's create a new branch for him. So feature use case 3 user 1. So that's the branch for him. That's the one. And let's do the same for the second user. So second user is here. This is his virtual machine. Let's go to his branches and let's create a new branch for him. So feature user 2 use case 3 branch. Alright, so that's the branch. And now we want to modify some file by two users in the same line. So again, let's work on this code-free file. And this time, let's say we will be modifying this middle line. So here, let's say, I got to edit it first. Yep. Change made by user 2 case use case 3. Like so. So let's commit this. And let's merge to the master branch by using a pull request standard process. And me, as Piotr, I will approve this. Yes, please approve and complete. So the change made by the second user is already in the master branch, which is fine. And now let's jump back into user one environment. So this is it. And let's modify the same line, this line. So hopefully this time we will have a merge conflict. So let's modify. And here are some changes made by user one. All right, let's commit this. And take note that committing works without any issues, because commit means save changes in my branch. And there are no conflicts involved at all. And now let's try to merge those changes to the master branch. And take a note, finally, we've got something called merge conflict. So Git detected that, hey, there were some other changes made in the same file, in the same place that you are trying to modify, and me as Git, I am not able to handle it on my own. Sorry, you have to help me decide which changes should be used in the final version. So now, the person that is creating the pull request, the author of the changes, he might be able to resolve this merge conflict. And we can clearly see that the issue is in this code.txt file, which has been edited in both places, in our source branch and in a branch to which we want to merge our changes. And now how to handle it? And I installed this extension called pull request merge conflict. That is an extension to Azure DevOps. And once it is installed, we have this additional tab called conflicts that we can use to quite easily solve those conflicts using a web browser. And in many cases, this is enough. This web interface is good enough to handle conflicts. So let's see what we have there. So first of all, we can see that the issue is in our code.txt file, only in a single file. In more complex cases, you'll have multiple conflicts in multiple files. In our case, it's only this code.txt one. And then on the right hand side, we've got 3 areas that I want to talk about. So the first one that is important is this one. And this shows our source changes, or a version of the file that we want to merge into our target branch. And we can see that the source is from our feature branch, and it was modified by user one on this particular date. And we can see the content of the file with the marked area that is causing the conflict. On the right hand side, you can see the destination, our target branch. In our case, this is a master branch. We can see that the last change is made by user 2 because we approved his pull request. And again, we can see this conflicting area. And at the bottom, you will see the merged version. So this is the place where you can see how the merged file will look like after resolving the conflict. And here by default, Azure DevOps, Git, and this extension is showing you exactly which area of this file is conflicting. So this part, you can see that's the one version of the file. And just below, we've got the other version. And we can see that this is the area that differs in 2 versions. And we've got to handle it somehow. And now, depending on the case, we might say, all right, I don't want to bother in solving those issues line by line, and I just want to take whatever is in this version, because that's the proper one, or whatever is in this version. And to do this, you would use this option and either keep whole target, which is this one. In our case, we would just take the stuff that is available right now in the master branch, Or we might say, no, I want to take whatever is coming from the feature branch. So take the stuff from our user1 branch. But in those cases, you will lose some changes made by the other person, right? So be very careful when you do this. And by the way, take a look how it impacts the target. So let's say you want to keep the right stuff. And it resulted that the second line, that's the one that we were working on, it contains only the change made by user 2, because that's the version that was already stored in the master branch, which means that we are losing the changes made by the user 1. And maybe that's not the right approach. So let's resolve this conflict again. So let's reset the stuff. Likewise, we could say, all right, take the stuff from our feature branch. So take left file. But again, in this case, our resolution will contain only the changes that were made by the first user, and we will be losing the changes made by the second user. So maybe not the optimal approach. Of course, it depends on your case. So let me resolve it again. And actually, in this case, we'll handle this manually because we want to keep both versions. And to make it work, we'll manually modify this target file that is displayed at the bottom. It is editable. So what I will do is, first of all, I want to remove those markers because they are just helpers to indicate where the conflict is. We want to have them in the final version of the code. So let me remove this. Then we know that we have this change and this change to be included in the final version. So it's up to me to decide how to merge them. And let's say that I want to have the change made by the user 2 first, and then append the change made by the user 1. So I will copy this and paste it here. Just copy and paste stuff. And then I will remove everything else that I don't want to have, including this marker. All right. And this way, I resolved the conflict manually. I told Git explicitly how I wanted this specific conflict to be resolved. And if I'm happy with the way it looks, I will just submit the merge. So let's click this. And now you can see that the icon changed to this green tick box, meaning that conflict is handled. What I personally like to do before I approve the pull request is to verify that everything looks fine. And to make this work, we could use those three views. So the first one, source resolution diff, it will show you the difference between data coming from the source branch, in this case our feature branch, and the changes that we made as final, with difference between our source branch and with our file after we handled the merge conflict. So let's see how they differ. And actually, let me hide this to make a little bit more space. And you can see that in the source, we've got only this change made by user 1, but in the final version, we've got both of them. So that's the change made by the second user that we decided to keep. And also we have the change made by the first user. So that's how it looks like. Similarly, we can compare our target branch, in this case our master, with the version after the merge conflict was handled. So our master branch, our target branch, contained only the change made by the second user, and in the way in the file we handled, we have both changes. And the final view is a view that compares the conflict as it was originally with the version that contains our way of handling this. So again, quite useful to verify that everything looks fine. And let's say that we are happy with this, and based on our policies we have to resolve every comment and every conflict. It results in a comment. So basically I want to make sure that yes, I resolved this conflict, I submitted the resolution, and let me mark it as resolved. So come on, this one, because I did it multiple times. So let me resolve all of those comments. And is there anything else that is not resolved? Any comment? No, everything is fine. So the pull request approver can now review and approve the change. So let's jump to my environment. Let's take a look at pull requests. That's the one. And I could see what has changed, what the conflict was handled in which way, and if I'm fine with this, I can approve and merge the changes. So let's say it is fine. The user 1 handled the conflict properly. So let me approve this and complete it. And once it is done, let's see how the code version in the master branch will look like after merging those changes to the master branch. So if we go into our code file, we can see that yes, we've got those two changes. Change made by the second user and change made by the first user. And we did this. So that's an example of a conflict. Basically when two users made a change in the same part of the code in the same file. And Git was not able to handle this, but we helped him. But we did this through a web browser. Now, sometimes this web browser is not good enough. Or maybe you are working locally and you don't have a web browser available. So how to do this without it? And yes, it is possible in a Visual Studio Code. So let me show you the final use case where we will handle a merge conflict locally using a Visual Studio Code. So let me switch to user 1 environment, to VS Code. It is here. And let's make some changes here. And actually you will see that sometimes it can be you who is causing the conflict. And in this case, we'll do exactly this. So as user 1, I will create two branches from the same master branch. The first one will be merged into the master faster than the second one, and both of them will make changes in the same part of the code in the same file, because we know that this triggers the conflict. And please note that I'm working on my local repository. We didn't pull the changes from the remote repo, so don't be surprised that in my branch, actually let me switch to master branch. So don't be surprised that we have only documentation directory. We don't have this code because the version of the code that I have locally doesn't contain those changes. But that's fine. At this moment, I just want to show you how to handle merge conflicts locally. All right, so we will be working on this intro.txt file. So let's create a new branch from this master branch. So we know already that to create a new branch, we can use create branch from master, and let's call it branch A. All right. And we would like to modify our intro.txt file and make some change. So change made in branch A, like so. Let me save this and let me commit it to my local repository. Basically, we want to harden those changes. We want to make them available in the local repository. Branch A commit. So let's commit this. Yes, please do. So right now, in my master branch, we have those changes made by this user from branch A. Now, let's create a new branch. Create branch from master, and let's call it branch B. And now, by the way, take a look that the content of our intro.txt file changed, because in our master branch, we don't have those changes yet that were made in the branch A, right? And let's make a change here. Additional changes coming from branch B, like so. Let me commit those changes. Yes, please. Oh, I forgot to add a commit message. So actually, commit from branch B. Let me commit this. All right. So right now, our both branches, branch A and branch B, contains changes in the same file. Now, if we change the branch to master, you will see that master doesn't contain any of those changes, any of those branches yet, because we didn't merge them. So let's start with the first branch, with the branch A. So yes, please, I want to merge changes from branch A to our master branch, and it's done. We don't have to bother with any pull requests because it's my local environment and I can do whatever I want here. So right now, our code in the master branch contains already changes coming from the branch A. Cool. Now, what if I would like to merge also changes from branch B to the master branch? And let's see what will happen. And you should see already or predict that we'll have a conflict. So branch B, oh, come on. And we've got a conflict that we would like to resolve somehow. And now, in VS Code, we have something called merge editor, which is pretty cool. Something similar to the web extension. And it will allow us to resolve this conflict. So let's open this. And now, what do we have here? Something similar. So we've got three places. One version, the second version, and the result of the merge at the bottom. All right, so those are incoming changes, the stuff that we want to merge into our target branch. And we can see that they contain those additional changes from branch B. This window, it's our current version, our target. In this case, this is our master branch, which contains changes from branch A. And at the bottom, we have the result, how the file after the merge will look like. And again, we've got here those blue links that allow us to easily accept specific part of the code. Also, we have those options to accept the stuff from this specific site at all, right? But let's say that we would like to combine those two changes, and it's up to us to decide in which order we want to make them. So let's say that in our first attempt, we will first would like to get changes from this branch and then from this. So to make this work, let's say that we would use this one. So we want to accept a combination from both branches, and we want to take this branch first. So let's click this and see what happened. In our result, we see that this part is coming from branch B, followed by changes from branch A. So that's the order. B first, then A. But let's say that now it doesn't look the way we would like it to be. So let me reset our merge process and let's use a different combination. So this one. So in this case, changes from branch A are the first ones, and then followed by changes from branch B. Not really. So let's reset it again. And here we can do our own manual resolution. And please know that we don't have to just copy those files as they are. We can, like so. We can add also additional. We can do it like this, right? So we can modify the file in the way we want during the merge process. But let's say that no, let's reset this again. So you can see that you can do it over and over again until you are happy with the outcome. So let's say that we would like to keep the order in which the changes were made, which means that changes from branch A should be stored as the first ones, followed by changes from the branch B, which means that this option should work just fine. So yes, please. And let's say that we are happy with the way it looks as the result, and let's just complete the merge. That's fine. And we just have to commit those changes to our master branch. Yes, please. And it's done. So we handled the merge conflict locally in VS Code. And the result is that, well, we have the changes from both branches in exactly the order in which we wanted them to have. All right, and basically that's it for today. So to summarize, merge conflicts will happen. They are normal, especially in case of bigger teams, and don't panic if you spot them. The thing is that the longer you wait with merging your changes to the target branch, the bigger the chance is that you will have those conflicts. So don't rather keep your branch unmerged for half a year, because you will have a hard time trying to merge it. But when it happens, you have various options to handle it. You can use this web browser extension that provides some basic functionality. In many cases, it is fine. You can also use this merge editor in VS Code. That also works pretty well. Or maybe you are using some third-party tool that also should have some merge conflict resolving capabilities. And that's it. Thanks for watching and see you next time. Take care.